Now we are going to take up the topic law of conservation of mass. So first of all, the question comes in mind, why we are studying this topic under this, we are not considering the mass, we are just considering the matter. So I would like you to know that we are doing this topic to explain the behavior of matter, that is the main property of matter, that is indestructibility of matter. What does it mean? It means matter can't be created nor be destroyed. Keep in mind please, matter can't be created nor be destroyed. Now, from where does this came from that matter can't be created nor be destroyed? So, it came from the postulate of Dalton. Dalton said that matter is made up of atom. Matter is made up of atom. And he also postulated and proved that atom can't be created and nor be destroyed. We cannot create atom and we cannot destroy atom. So that means it is applicable to matter as well, that matter can't be created nor be destroyed. So this leads to the formulation of the law of conservation of mass. Actually this law of conservation of mass is obeyed by the chemical reactions. It is obeyed by the chemical reaction. Now the question must be coming in your mind, what do you mean by the chemical reaction? What exactly the chemical reaction is? So before we take this topic, law of conservation of mass, I want you to know that what actually the chemical reaction is. See, chemical reaction is a process in which some substances are mixed and some new substances are formed. This, can be this, anything. So I'll explain you from the daily example. See, when you make tea, how you make tea? You take a pan, right? What you add into it? You add water, you add this thing milk, you add tea leaves, you add sugar, and after when you supply heat, what happens? It turns into a tea. When you sip a tea or when you see a tea, what do you see? Are you able to see the tea leaves? No, you are not able to. Are you able to see the milk? Are you able to see the water? No. They all unite to form a single substance. So this is how the chemical reaction takes place. So that is also a chemical reaction. One more example is coming in my mind. See, you take this thing milk, what you add? You add a small, say a spoon of this thing, curd to it, stir it well, and you keep it aside wrapped by a warm cloth or something like that. What happens when you look in the evening? What happens? It turns into the curd. That is also a chemical reaction. Similarly, one more example from your daily routine. You take a milk, you add you can say a few drops of vinegar to it, and you heat it. What happens? It changes into the cheese. That is also a chemical reaction. You don't get to see the vinegar drops or milk in it. You get a single substance, that is cheese. They are all chemical reactions which are taking place. So coming to the point, what is actually the chemical reaction? It is a reaction in which some substances are mixed and some new substances are formed. So the substances which we mix are called as reactants, and the new one which is the result of the reaction is called as product. So I am repeating a definition for you, listen to it. Chemical reaction is a process in which some substances are mixed, that is the reactants are mixed, they unite to form the product. That means old bonds are broken and new bonds are formed. So chemical reaction is a process in which reactants react to form products. See, and representation of chemical reaction is done with the help of chemical equation. What we do in chemical equation? See, we have two types of method to represent. One is word equation and other is chemical equation. Word equation, see, if I take an example, carbon plus oxygen, plus means we are mixing them. Okay, so carbon plus oxygen give rise is indicated by an arrow, carbon dioxide. So this is a method to represent chemical reaction in terms of word equation. And if we wish to represent in terms of chemical equation, how we will do that? We will use the symbols for it. We know for the symbol of carbon it is C, oxygen symbol is O, but it exists as O2 because oxygen is gas. Give rise to means again arrow, and it will form carbon dioxide, so we will use a molecular formula. So molecular formula for carbon dioxide is CO2. So this is the method to represent the chemical reaction. See, I'm telling you this chemical reaction because I want you to know the law of conservation of mass in a proper manner. So before you do this, you should be familiar with the term chemical reaction, chemical equation, because I'll be using in the topic now. So I think it is clear now. So now coming to the point that what is the law of conservation of mass and how it came and who proved it. So there was a scientist, Lendolt. Who? Lendolt. He performed an experiment and proved this law of conservation of mass. How? He took the Lendolt's tube. He had a tube, H-shaped tube, which was named after his name. That is H-shaped tube called as Lendolt's tube. Look carefully, what is it exactly? It is the glass tube which resemble the H shape, sealed from both the sides, top and bottom like it. What happened? He took a solution in it, let it say NaCl, and one solution in this arm, AgNO3. As you all know, NaCl is sodium chloride and AgNO3 is silver nitrate. So this half arm was filled by with AgNO3 and this half arm was filled by NaCl. What he did? He weighed this tube. So let us say the weight comes out to be W1. Then what he did? He now shaked this tube. He shaked this tube. So what happened? These two solutions got mixed. So when they got mixed, so obviously they must be reacting. So what was the reaction involved? It was NaCl, AgNO3, both got mixed and they give rise to, we know that this, I am writing the valencies here. These are the valencies which are used. You don't need to write, actually you need to remember them in mind, but I am writing for your convenience sake so that you are able to make the molecular formulas accordingly. That this should not come in your mind that where this 3 has gone or where this 1 has gone, right? So what will happen? This positive part will react with this negative part and this will react with this. So what happened? It forms NaNO3 and AgCl, that is sodium nitrate and silver chloride. Then that means after shaking it, this solution no longer remains this NaCl and AgNO3. This is now formed as this. So after doing it, that means when he knew that the reaction has taken place, he again weighed the tube. Let it say that weight comes out to be W2, and you will be surprised to know that the weight before an experiment, before the mixing of NaCl and AgNO3 was equal to the weight after mixing. So this shows that the matter cannot be created nor be destroyed, it is always conserved. So it leads to the formulation of this law of conservation of mass, which states that in a chemical reaction, matter is always conserved. That is, the mass of reactant is always equal to the mass of product. So we can also illustrate by taking into account their masses. See, before we know the atomic mass of Na is 23 and for chlorine it is 35.5, for silver it is 108, for nitrogen it is 14 and for oxygen it is 16. So let us see the mass weight of mass of the reactants first. So how we calculate the mass of NaCl? Na is 1, so I take it as 23. Two different atoms, we put plus sign. Cl is 35.5. Now taking into account AgNO3, Ag is 108. Ag and N both are different, so I am putting plus. N is 1, atomic mass of 1N is 14, so I am putting 14. N and O different atoms, so again we will be putting plus. 3 atoms of oxygen and 1 atom weighs 16, so that means 3 weighs this much. So similarly for it, NaNO3, Na is 23, N is again 1 atom 14, 3 into oxygen is 16, so 16. AgCl, Ag is 108, Cl is 1 atom, so 35.5. So when you will solve it, you will get to see the mass of these reactants was matching with the mass of the product. You can easily add them and you will see the result is totally same. Let it say this is X and this is Y. The total of this reactant and total of this product is Y. So we will get to see that the values of X and Y is same. That means mass of reactant is always equal to the mass of product. This shows that mass can neither be created nor be destroyed in any chemical reaction. It is always conserved.